Hello everyone, welcome to webinar on MIDAS Design Plus software solution, which is the software solution for component design of RC steel, SRC as well as aluminium members. I would like to firstly help you understand with the GoToWebinar. So if you have got any questions in between, you can write your questions at the questions box, and if you're not able to hear me, you can just raise your hand over here. We will be beginning our webinar now. So in today's webinar session, we are going to look at the introduction to MIDAS software solutions, that is from MIDAS IT. We will look at the applications of MIDAS Design Plus, the design codes and components that are designed using this software. We'll have a demonstration on an irregular column design, multi-storied basement wall, moment bolted connection, base plate design, CFRP strengthening, and aluminium design. So let me begin with a short introduction to MIDAS as a software company. It was established in the year 1989, and since then all the software solutions have been distributed in more than 120 countries. There are more than 540 number of employees and more than 18,000 number of clients, more than 60,000 number of users worldwide. In total, we have 9 branches all over the world, with our headquarters in South Korea in Seoul. So our branches are in MIDAS China, USA, India, Japan, UK, Russia, Singapore, Philippines, and lately we have opened up a branch in Middle East, that is UAE. MIDAS has 2 main business areas, one in engineering consultancy and the other in software developments. So the consultancy goes on in the sector for bridges, buildings, geotechnical and mechanical, and with respect to the engineering consultancy requirements, the softwares have been developed to meet the practical requirements of optimization. These are this is a partial list of worldwide users. So you might be knowing few or maybe all of them. Let's look at the users in the Middle East. So these companies have used one or more than one software solutions of MIDAS. In the educational sector, these are the universities that are using MIDAS software solutions. Let us look into what all software solutions is MIDAS actually offering its users. Well, MIDAS has 4 main family programs. One is in bridge, structures, geotechnical and mechanical. In the bridges family program, we have MIDAS Civil and MIDAS FEA. Civil is for integrated system for solution system for bridges and civil structures. You can easily analyze and design simple as well as complex bridges in very short period of time and accurately in MIDAS Civil. Then in MIDAS FEA, you can perform advanced non-linear and detailed analysis system. So you can actually perform impact analysis, contact analysis, and you can perform total strain crack analysis, and yeah, so there are like detailed analysis systems required in case of joints, in case of bolt connections, and so on. Then coming to the structures family programs, there is MIDAS Gen, MIDAS D-Shop, and MIDAS Design Plus. So in MIDAS Gen software solution, you can perform analysis and design of simple buildings or high-rise buildings or even steel structures as well as you can use general structures in MIDAS Gen to perform the analysis and design. Then MIDAS D-Shop is a software solution that is used for drafting automatically the rebar arrangements that we get from MIDAS Gen software solution. It can also generate bill of materials. And there is MIDAS Design Plus, which we will be seeing today, which is a structural component design and detailing tool. Also, it has got connection with MIDAS Gen software, so you perform a global analysis of the structure, a 3D structure in MIDAS Gen software, take the analysis results from MIDAS Gen to MIDAS Design Plus by one click, so importing function is available, and you can perform component design in MIDAS Design Plus. That's about the structural solutions that is offered by MIDAS. Further moving to the geotechnical, there is GTS NX, which is a 3D geotechnical software solution based on finite element analysis. And there is SolidWorks, which is a 2D geotechnical software solution also based on finite element. In addition to finite element, it has got analytical geotechnical solution. Its theoretical solutions are also available in SolidWorks. Easy to use software solutions, that's what we can talk about SolidWorks. Then further we have mechanical family programs, that is MIDAS NFX and MIDAS FX Plus. MIDAS NFX could be useful in case of civil engineering when we want to perform CFD analysis, 3D CFD analysis for, let's say, high-rise buildings or bridges. So that's about the software solutions offered by MIDAS. Now let us move ahead to the introduction to MIDAS Design Plus software solution. MIDAS Design Plus software solution offers structural component design for slabs, beams, columns, shear walls, footings, basement walls, buttress, stairs, corbel brackets, beam tables. That's not actually the design, but these are the tables that have been offered, and yeah, batch wall design is there. That's about the RC. And coming to the steel, there is beam column design, check actually, not design. And further there is base plate design, bolt connection, in which shear connection and moment bolt connection is available. Crane girder design is there, purlin press girth design, web opening and staircase design is available. Then we have steel reinforced concrete, that is composite type of beams, columns and CFD type of columns also designs available. And there is aluminium design also available for beam and column. So this basically, these options that you can see over here, these are also based on which code that we are using. So in MIDAS Design Plus, today we are going to see the American Standard ACI. Now let's talk about the inputs and outputs that MIDAS Design Plus is in connection with. So inputs can be given manually by the user. It can also be taken from MIDAS Gen, and when it comes to output, we can get the output in the form of Excel sheets, in the form of Word file, a detailed Word file, and MIDAS Design Plus is also capable of generating drawings. So you can get the output for AutoCAD files as well. Let's look at the codes that are offered by MIDAS Design Plus. So Design Plus actually follows these three codes that we can see: ACI, Eurocode and the Aluminium Association. When it comes to ACI code, we have a number of design components available for designing purpose, and Eurocodes have got few. There are more going to be added in future, and these are for the aluminium design, the Aluminium Association is used. So that's about the design standards that are available in MIDAS Design Plus. And now we will move ahead to the demonstration for different components. So we will look one by one. All of them are there, of course, but we will look at few of them so that you can get an idea how to work with MIDAS Design Plus. It's actually a very easy to use tool and can get you drawings and can get you detailed calculation sheets very easily. So here is an demonstration for irregular. Here is a demonstration for irregular column design, and I'm taking this shape as an example. So I'll open up MIDAS Design Plus right now. So this is MIDAS Design Plus software solution. This is the user interface of it, and we have got the ribbon menu at the top. So it has got different components for the design purpose. We can link MIDAS Design Plus with MIDAS Gen software solution, which is our analysis and design system, and that can be linked from here. Then codes can be modified from this tree menu, and we have got separate tree menus for different types of designs like RC design, steel, SRC, aluminium, and that's a separate reinforcement option that is available. So let's go ahead to the RC first and irregular column design, but for that we need to change the code ACI 31814 to ACI 318M14. This is important because we are going to be using the metric system, and for getting the results in the metric system format you need to use ACI 318M14, 14 as in the latest standard. Then further we can see here that there are target ratios that can be set for different components of design, and we can click on apply. So after you click on apply, the dialog box automatically closes, and we can see over here the next part that is required to be done, which is rebar code. This rebar code is ASTM, so in case you're using the same format, it's alright. If not, you can modify it by double clicking on the rebar code and changing it. For example, changing it to BSEN. So you can make combination of different codes. Now to get to the metric system, you can change the unit system at any point of time while you're performing the design. So we can do the modifications. Then further, let's look at certain design options that have been provided by the Design Plus software solution. Okay, here is the design capacity ratios that the program can check with. You can actually have the user-defined design capacity ratios for compression, tension, bending, shear, and other design checks. All you need to do is check on the option and modify the demand capacity ratios. So instead, not just one single component demand capacity ratio, but in that particular member itself you can have different design capacity ratios for each type of check. So that's for RC. Similarly, we have for steel, SRC, aluminium, and that's the reinforcement information for the slab, beam, and column. That's for the CFRP. Then further you can choose what should be the increment for getting the design result, like the shape of a footing. So what should be the size of the footing, or what should be the size of the base plate. So all that information you can specify over here, like with how much of length should the program increase the dimensions of the member to be designed. So that information is right over here. And further you can ask the program to change the section dimensions by itself until the demand capacity ratios are met with, until the member is passing, or you can have your own section dimensions checked by the program. So we will see all these options available So shear wall for steel, that's in case of base plate, and SRC, and further there is reinforcement as in CFRP information. So let's use the automatic option, the default options available, and then further there are options to control the drawings generated by MIDAS Design Plus. So you can control the layers and where the file would be saved and the drawings that would be generated, so which all drawings should be generated and how they should be generated. So all these information can be set from here, and once this information is set in MIDAS Design Plus, no need to modify it again and again. So that can be done basically once and forgotten for the rest of your projects. So that's one thing. Next is about the preference. So in the preference, you can actually choose which mode of the Design Plus software solution you want to use. Now there are 3 modes in MIDAS Design Plus. There is simple mode, project mode, and check mode. Simple mode is basically wherein you'll only get the calculation, and project mode is when you'll get all the information like calculation drawings, reports, quantities, and GenLink. So that's project mode, which we will be using. And then there is check mode. So check mode is wherein you cannot do modification in the inputs. You will only be able to see the output. This can be useful when you want to give a certain project file to for checking to your colleague or some third-party checker. So that's the use of these 3 different modes for the interface of Design Plus. Let's go ahead without any further delay, and we will start with the column design. So that is irregular column design. So we can just click over here and we'll see a list of different types of columns. There's column, general section column, and reinforced column. Reinforced column is actually the CFRP column which we can see today. And here there is general section column for irregular column design. Now this is where the shape is to be firstly defined, and we can do the definition with the help of the CAD files, or we can do the definition with the help of MIDAS section file. So MIDAS SCC, so in case you're using MIDAS Gen software solution, you can create the irregular column in the SPC, that is section property calculator, and import it here in MIDAS Design Plus. So we are going to be importing CAD file for this webinar session. We'll just click on import, and yeah, before we go ahead, let's use the SI unit system and then move ahead to importing. So it's because my CAD file is in MM, that's the reason why importing is the unit system has to be modified. So here we can actually select the layers for the outline of our cross section, and also we can have layers for the points where the rebars are going to be placed. So we can actually select that one as well. So we have selected the section. Okay, we have autosave feature in Design Plus, so I've saved it, and okay. So here we go, we have got the irregular shaped column from AutoCAD import. Further, we can choose to specify number of rebars to be applied to this particular cross section, and the diameter of bar as well can be chosen from here. Then further, we need to, of course, specify the information like the material property for the concrete and the rebars, what is the height of our column and the effective length of our columns. So again, the K factor, Kx and Ky, that is for the major and minor direction, can be set from here. So you can basically select from here and just click on apply likewise. And then go ahead to the splicing information. So By default, we have kept it as 50% splicing, then equivalent area for general section. So once we have imported this information, we can just click on update size, and the program will automatically give us the width and height of the equivalent area of this general section. So this is done. Next, let's move ahead to the section 2 tab right over here, wherein the clear cover can be specified, and we can specify over here the stirrup information. Okay, sorry for the delay. Yes, so we are going to provide the information over here regarding the hoop bars and the tie bars as well, which would be applicable for shear check. That's again depending on our requirement. Now let's provide the information regarding the forces. Now this information can be again taken directly from Gen if there is a link. Otherwise, we can get it over here. So let me put the information that I have already taken. So we have 3656 kilonewton as the actual force. I'll be applying it to shear check and further moments. So it's 138.3 in both the directions. And the shear is 66.5 for both directions. Then the coefficient factors again can be set over here, and we can move ahead now to perform the check. So this is the check for the reinforcement arrangement that I had provided, and this is the information that we get directly in the form of summary. And at this side, the report is generated. It's a simple report, not a detailed report as such, but if you want to go for a detailed report, you can click over here to get the detailed report. This is for quickly viewing how the program has performed the design. You can also click on design over here to get the optimized number of rebars. Now in the shear capacity check, we can see here the reinforcement spacing is not good enough. So we need to check with the hoop bar spacings right over here. So it's instead of P5, we'll use P10 and we can check that part. So now it is okay with the spacing of 300 mm each. So this is done. We are set with our results, and now we will go ahead and generate the reports. So those can be generated from here. You can have it in the form of text file or a Word detail file. So in this way, you will get a detailed calculation sheet for the irregular column design performed as per the ACI standard. Okay, so this is the Word file that is generated by MIDAS Design Plus. Let's look at what all design information that we are getting. So this is basically giving us information for the inputs that has been applied. The section information, we get a nice drawing of it as well, and the forces that are applied to it. The rebar arrangement information, the slenderness check is also performed. Magnified moment calculation. This is actually the one that we have provided. So that is a user input value. Then minimum moment calculation, design moment, and the parameters calculation is given right over here. And the moment capacity check has been performed. So that is satisfactory. We also get the PM interaction diagram, and lastly the shear check capacity. So everything is okay, and we can move ahead to the next part of MIDAS Design Plus. Now this result we have seen in the form of a small summary here, and we have seen it in the Word file format. We can also get the information in the form of Excel sheet, so that's the member list information, and we can get a drawing also generated by simply clicking on create. So a drawing for this particular irregular column is generated, specifying the information about the reinforcement, and this can be saved as a .dwg file. So you can see here DWG-DXF files or bitmap files can be generated out of the drawings that are given in MIDAS Design Plus. So that's about the drawings, and further we have got quantity as well that can be generated for this column. So we get the concrete volume in meter cube, and we can change the unit system and get the value for the reinforcement and the formwork in the form of tons and meter square. So totally depends on the unit system that we are using. Again, this can be exported to Excel sheet. So these are the different ways of outputs that can be generated from Design Plus software solution. So that was about the irregular column design. Now let us move ahead to the next design component, and that's the multi-story basement wall. So here we can have multiple basements, and for those the basement walls can be designed in MIDAS Design Plus software solution. Also, MIDAS Design Plus is capable of designing retaining walls. So we are going to be seeing the basement wall design at the moment in this webinar. So again, we will be back to the Design Plus software solution, and we will go to the mode member, and we will choose the basement wall from here. So cantilever retaining wall is also there. That's another option, and basement wall is what we'll see right now. So this is the basement wall interface. Again, it's very easy. All we have to do is provide the material properties, main reinforcement grade and sub-reinforcement grades. You can select from the drop down, or you can apply your own value as well. Then further we have two types of sections, that is one-way type of reinforcement arrangement, or we can have two-way type of reinforcement arrangement for our basement wall. So we'll see the one-way type right now, and then the clear cover is to be provided. To increase the number of basements, you can just click on add over here, and you can adjust the heights of each basement and also the thickness of the wall for each basement. Then further, there is the loading information. So this loading information can be done by user, wherein the force and the level will be given by us itself. and the program is automatically able to calculate the soil from the soil property what will be the surcharge load and the pressure variation throughout the height of our basement wall. So let's give this information. Let's provide 5 kilonewton per meter square as a surcharge, and let's have the level of the first floor. So let's keep it as 0. So this is the first floor level. It's going to start directly after the first basement or 1F level. And then there is water level. So you can choose to modify the water level height. Maybe the water table is some 3 meters below. So you can write -3 over here. And then further there is a soil factor. So you can choose among these, or you can type your own soil factor and water factor. And after that, again, the soil properties. Now you can have one soil property throughout the height of your basement, or you can have multiple densities throughout the height of your basement. So for that, you can just simply specify over here the density and the height, also the friction angle of friction. So right now I'm keeping it as one value itself, and we can go ahead with the boundary conditions. So boundary conditions, right now it's going to be bottom fixed and top will be pinned. So this is the way for performing the analysis. I mean the boundary condition provided for the basement analysis. Then further we can go ahead now and yeah, let's just go ahead to perform the design. So you'll just click on design right over here. Alright, so design has been performed, and we can see over here an image which is dynamically created by the program. You can see what is the reinforcement arrangement provided, and that is again visible over here at the sides. So in case you would like to modify the reinforcement information, then you can do that from here directly. So let's say you want to go for P16 and instead of P13 or P12 likewise, then you can, after doing the modifications, just click on check and see if this reinforcement arrangement is good enough or not. So you will get the okay, not good kind of remarks from the software itself. This is for the basement 1. Basement 2 also you can do the modifications and check whether the design is alright or not good. Further over here itself, in this dynamic image, you can see the section and rebar pattern, and you can also see the soil map and loading. So this is the not the reinforcement, the load information that the program shows in the form of a diagram. Also, you must have noticed over here at the side the report generated, a detailed report generated. You can see the moment capacity diagram, the shear capacity diagram is given, and this entirely can be printed in the form of Word document. So again, a Word detail file can be generated easily for the basement wall design. Further, let's look into the results document. So this is the Word file generated for the basement wall. So we get the initial image of our basement wall. It's a one-way type of basement wall, and soil loading, the calculated soil pressure. You can see what the formulae that have been used for the calculation, and further we can check out the moments and the shear forces in the basement wall, and that's all that we require basically. So this can be readily used as a report for a basement wall design. Let's get back to Design Plus. So Design Plus is also capable of providing the drawing for the basement wall. So let's just click on Create, and this is the basement wall information that we can get. And also we are able to generate the quantity for the basement wall. So for each basement separately we can get the values B1 and B2, which can be again exported to Excel sheets. So that was about the basement wall for multi-story basements. Let me go ahead to back to the presentation slide now, and we will move to the next part of design component example, which is moment bolt connection. So for that, we will go back to the members over here. In the member page, we can see the steel types of components that are available. So herein we are going to simply check out what are the options selected for the code for design of the steel, and the material database and the section code that is being used. So if in case some modifications are required, those can be done here itself. So let's start with the moment bolt connection. Alright, so now we have this image right over here that shows the plan elevation and the side view of our beam and column, and we are going to be looking at the information for the section shapes. So we can actually select from the predefined database that is given in the Design Plus software solution. So this is actually not it. We can add more number of section shapes over here, and in case we are not using the code based section shapes, then we can uncheck this option for use database and provide our own information like H, B, DW, TF and R, that is the thickness for the web and the flange and the radii. So this is information for the shape, and after that stiffeners. So if you would like to use the stiffeners or not at the top as well as at the bottom, you can directly or dynamically see in this image what modifications you're doing. And over here there is the thickness information, width for the stiffeners itself, and after that let's go ahead to the information for the girder. So right now we had seen about the column information. Now the girder information, again the material property is to be selected, the section shape is to be selected, and if any stiffeners are to be utilized, so likewise we can add those, and the thickness, material properties can be modified, edge length and so on. So that's for the column and girder, and after that the plate. So you can provide the information for the plate thickness and the extension of this plate beyond the column likewise, and also regarding the welding. So what material property you would like to use for the welding, and what should be the welding thickness at the web, at the flange, and for the stiffeners. So there is information that we can provide. And lastly, of course, we need to provide over here the information for the force. So you can apply expected yield stress instead of the forces, that is moments and shear forces, or you can directly go over here and provide the force value. So just for an example, I'm keeping these force values, and then the design parameters can be specified right over here. Apart from that, there are material properties for the bolt that can be selected. So this is the American material properties and bolt properties that are available, but you can do the modification. You can change the material database from here. So you just have to double click and change the material information. For example, you're using BS standard, British standard for the steel database, and you can click on apply. So you can click on OK, and likewise you can choose the bolt material and the size of the bolt. Likewise, so you can see over here directly what would be the spacings for between each bolt. All these things can be provided by us directly. Can consider the thicknesses for the web and the flange, and after that the layout for the bolts are specified right over here at the top and bottom. And once all this information is provided, which is actually very easy to understand, so you can go ahead and perform the check. Let me go to the column firstly and specify the material, since we had changed the material property. And over here let's select this section. So since we had modified the section properties, we need to take care that all this information is provided. So similarly for the plate, yes, now that's fine. We can go ahead for the check. Alright, so the check is performed, and we can see the information right over here in the report at the side. We can also perform the design and see what should be the number of bolts that require to sustain so much of moment and shear force. So this is the information provided by the program, and we can, similar to the previous component designs, we can generate the Word file reports. So, but in short, you can actually see from here itself what the Word file report would actually look like, a detailed calculation sheet would actually look like. You can see from here the formulae that have been used, verified with your practice. Yes, so that is about the moment bolt connection. And we can also generate the drawing for the moment bolt connection. So I would say that at least basic drawings are generated by Design Plus that can be used for can be arranged along with the rest of the drawings, or the like global drawings that you have. So there is save as option that you can use to create a DWG file format. And lastly, yeah, quantity is not there for the moment bolt connection. That's not required, I suppose. So drawings is more than sufficient. And let's go ahead now to the member. Next member. So the next one that we're going to look at is the base plate design in the steel part itself. So in the base plate design, we are going to see how the column can be connected using a base plate to a concrete pedestal. And we can choose if we want to see the design for the pedestal as well, or we want to ignore the pedestal and just get the results for the anchor bolts that are required. So let's go back to Design Plus software solution, and we will go for the base plate design. So here we can select the plate material property, the anchor bolt material properties, and the concrete material property for the pedestal. So let's say 25. And further we can specify the axial forces. So I'll just give a preliminary axial forces over here, and the moment information, and the shear as well. And we can select from here the section shape. Again, it's the same thing as we had seen earlier for the moment bolt connection. Select from the database or provide your own section shape. Then further we can get the base plate, provide the base plate dimensions over here by ourselves, or get the dimensions modified by the program. We can place it on a pedestal, and again for the pedestal as well, choose a shape. So this is actually done by the user itself, but for base plate the program can automatically find out the shape or the dimension. We can choose to use the wing plates over here, and We can have the rib plates as well. So all these options are available for us. And again, this is cast in place anchor bolt option only that we have, and the diameter can be chosen from here for the bolts. The length of the bolt for the anchorage, it's a J-shaped anchorage only that we have provided, and the position of each anchor bolt from the edge of the base plate is to be specified. And after that, let's go ahead and perform the design. Alright, so design has been performed and the program has asked to actually check to use actually the rib plates. So a number of rib plates have been used, and these are the number of bolts that the program has asked to use. And yet the rib plates, they are failing slightly because of the high moment. So we can do the modifications and we can do the checking, and we can have the pedestal rectangular or the circular type. Similarly, base plate can be of circular shape. So that's about the base plate design, and we can generate the drawings for the base plate as well. This will be the drawing that will be generated by the software. This workspace that you see over here is similar to CAD. You can use all the commands, the shortcut tools like L, enter, and just draw, and you can have M, enter, and move the location. So all these commands are applicable in this workspace. We call it as MIDAS CAD. So that's about the drawing generated by MIDAS Design Plus, and also the quantity. Quantity would be in case of the beam and column itself. So that gets us to the next type of component. That is CFRP strengthening. So CFRP strengthening can be done for beams, columns, as well as slabs in MIDAS Design Plus. So this is just an example that can be done. Before we go ahead over there, we have a query and a question that says that to provide only J-hooked anchors. So yes, we can provide only J-hooked anchors. If you want, you can remove the rib plates and you can perform the check. Likewise. Alright, so let's get back to MIDAS Design Plus and see how the CFRP strengthening works. So we will go to the screen for Design Plus, and let us open the list of members again. So here in the RC, we have got the option reinforced slab, reinforced beam, and reinforced column. So this is nothing but the CFRP design that is available. So let's say reinforced column or CFRP design for column. So you can see over here, these are the various options available. The reinforcement is FRP, carbon fiber. And we can provide the information regarding the exposure, if it's interior, exterior, or it's in the aggressive environment. And further reinforcement properties, you can specify if shear is to be checked, and further the material property for the CFRP. So you can have user-defined type of material property as well specified over here. And you can have carbon, glass or aramid type of fibers included. So that's fiber reinforced uh, jacketing that can be done. And after that we can specify the information about the column. So you can get it from the RC column itself directly when you have the column designed over here separately. Otherwise, you can go ahead with the information for the force and the reinforcement that has been used for that particular column. So here, let's provide the actual force and the moment. And here we will use the same information that we used for the irregular shaped column. So that's what we are going to do right now. And further, if you would like to apply some seismic special provisions, so those can be specified right over here. And after that, reinforcement arrangement. So there are 4 numbers of reinforcements that is specified. You can have more number of rows likewise. And the reinforcement arrangement for the like the reinforcement diameter used, and the center to center, the clear cover that has been used. Likewise. And after that, you can add more layers of reinforcements and the hoops, hoop bars that are there. And after that, the tie bar information and splicing information. So basically you provide all the information of the column which is to be reinforced, and after that you can do the checking. So after you do the checking, we can get the information over here. We get the PM interaction curve directly, and we will see the demand capacity ratios, the reinforcements that have been actually applied to this column. And if anywhere there is failure, you can check it, and you can get the detailed calculation sheet from the Word file report that is generated. So this is the check for the information that we have provided to the program. Let's see the design results. So the design results, this is again failing. So we need to modify the information a little bit, and we can specify the thickness as well. So basically modifying the properties or modifying the information would help us to solve the required strength, or help us to gain the required strength that is required for the newly applied loads. So that's about the CFRP. Yes, and this is similarly applicable for the beams and slabs. So that's about the MIDAS Design Plus for retrofitting purposes. And let's go back to our presentation. The next, the last type of design that we will look at right now is the aluminium design. So here aluminium design is there. We can simply look at the list, or we can go over here to the member. And we can specify over here what is the section of the aluminium, and these are the material properties and the product extrusions and the section shapes. So you can actually select likewise, or you can have your own section shape as well. And from here you can go ahead with the checking. So I'll just apply some arbitrary loads over here. And the deflection of in mm, it's like, let's say 2 mm deflection by wind loads and by the self weight. And the deflection criterias are actually provided right over here, so you can specify those accordingly. Check and specify those. Alright, let's perform the check. Oh yeah, we need to select. Just a moment. Okay, let me select the code over here, the design code. It's LRFD. It's in kilonewton meter. Think I need to check with this. I think I'm in the wrong database. LRFD is correct. Aluminium database. information for the moment of inertia. Okay, so we have got these checks basically performed for our structure, and we can get to see the information for in the report file format, the detailed calculation sheet. So that's about the aluminium design, and further we can also get the drawings generated for the aluminium. That will take a little time. So till then we'll look at the quantity. Yeah, quantity also that's not available for the aluminium. So we have got quantity in case of beam column, steel beam column, and we have got for the RC members. So that's about MIDAS Design Plus Software Solutions. Now let's get back to our presentation. Alright, thank you very much everyone for attending our webinar session on MIDAS Design Plus Software Solutions. So if you have got any questions, you can write at the questions box and we will get back to you personally through your emails. Alright, we'll be ending the session now. Again, thank you very much for attending and have a great day.